Alright, as we progress further in the gas laws, we've dealt with a question on Boyle's law in our previous class. Now we want to go on to deal with these two questions. We said the volume of a given gas is V centimeter cube. So watch the question now. They gave you the volume as V, which means V1 is V. At P millimeter mercury, P1 is P given to you. V is V1, P is P1. What is the new volume? You're looking for new volume, which means you're looking for V2 if the pressure is reduced to half, which means your final pressure has become what? Half of what you have before now. This is a question where they will not give you, this is jam question. I'm not going to give you numbers. So what do? It's still talking about Boyle's law. P1 V1 is equal to P2 V2. Your P1 is what? P. Your V1 is what? V. Then your P2 is what? P over 2. Then your V2 remains V2. So if I cross multiply, we have 2PV equals to PV2. And then going on, you divide P, you divide P, you have 2V to be what? V2. So your final volume, therefore, final volume is 2V centimeter cube. That's for that. Going on further now, question 2, the ratio of the initial to the final pressure. So what's the initial pressure? Initial pressure to the final pressure ratio is what? 1:1.5, which means initial ratio final is what? 1:1.5. By this it means P1 is 1, P2 is 1.5. Going on now, it says calculate the final volume of the gas if the initial volume was 300. So initial volume is 300 centimeter cube. You're looking for final volume also. So since it is with the relationship between pressure and volume, we talk about P1 V1 equals to P2 V2. What is your P1 now? 1. That's the ratio. Times your V1, 300. Your P2 now is what? 1.5 times your V2 unknown. When you multiply this, you have 300 equal to 1.5 V2. What then do you do next in this situation? You're going to divide by the coefficients, which is 300 over 1.5 as your what? V2. When you divide, you have 200 cm cube. That is going to be the answer for your volume in such situation. So going on further, let's take a question that involves all of this. The question here says 28.8 cm cube of nitrogen. 28.8 cm cube of nitrogen. That's the question. So let's take this as question number 3. 28.8 cm cube of nitrogen at 15 degrees Celsius is cooled to, so they are cooling it to 0 degrees Celsius at constant pressure. The new volume of the nitrogen is dash. We're looking for new volume. Already it is clear. What is clear? This is your first volume. This is the first temperature. The new volume I'm looking for, this is the second temperature. So if I am naming my properties now, I'll write V1 to be equals to 28.8 centimeter cube. V2 is unknown. T1 is 15 degrees Celsius. T2 is 0 degrees Celsius. Now our temperature in Celsius has to be converted. So you add 273. And this you add 273. This gives us 273. Then when you add 15 to 273 here, what's it going to give you? 288. So that gives us 288 degree Kelvin. This relationship between volume and temperature is talking about what? Charles' law. Charles' law says V1 over T1 is equals to V2 over T2. Your V1 is what? 228.8. Your T1 is 288. It's equal to your V2 unknown. Your T2 is 273. Then when you divide this left hand side, 28.8 divided by 288 here, you're going to have 0.1 equal to V2 over 273. Then you cross multiply. 0.1 times 273 equal to V2. So go ahead and multiply. Now you have 27.3 what? Centimeter cube. That is your new volume. So follow on. In our next class, we'll deal with other problems on pressure law and